Hi everybody, this is Keith Callaghan with myopenshiftblog.com. What I want to cover today is the article I wrote on rebuilding a master node. And what we're going to do for this presentation is I'm actually going to delete one of my master nodes. I'm actually going to delete master 1, and my cluster name's ansible.ocppocdemo.com. And what I'll do is I basically just want to show you an overview of some of the machine, basically the nodes I have in my cluster. I have 3 master servers and I have 3 workers. And in the console, I'm going to show you here that I have, when you do an OC get nodes, you're going to see all 6 nodes right now. And what I'm going to do to simulate a failure, I'm actually going to delete master 1. I'm going to show you currently that all the etcd pods are actually up. So I'm going to switch to the OpenShift etcd namespace or project. I'm going to do an OC get PO. Basically, you'll see right now all 3 etcd pods are up. What I'm going to do is I'm just going to RSH into one of these. And then we're going to run basically an etcd ctl command and point status and then -w table. And you're going to see right now all 3 etcd members are up. In the simulated failure, I'm going to go into my VMware cluster and basically just delete, I'm going to power this first master off. And then just delete the hard drive from it. Just go into settings. We're just going to delete this hard drive completely. And then what we'll do is just to prepare for when we rebuild this, I'm going to add the hard drive back. And I'm just using the default recommendation of 120 gigs for the master. So we're still in the OpenShift etcd project. So what I'm going to do now is I'm going to RSH into one of the pods. You'll see etcd master 1 still running, but it's when you try to connect to it, you'll notice we'll actually get a timeout. After a little bit of time, this pod should disappear as well, but. So right now, basically I'm getting no route to host. So we basically think the master is not all the way up since we deleted it. If you do an OC get nodes now, it's actually in a not ready state. But what we're going to do is let's RSH into one of the other pods, one of the other etcd pods. So let's go in the etcd master 2. We're going to run the same command we ran previously. etcd ctl endpoint status -w table. And you'll see now that the IP address. So master 1's IP address was 192.168.100.3. That's now off this list. So the only ones we see, the only etcd members we see now are the one that corresponded to master 2 and master 3. As you'll see from this output, the master 2 is the current leader. So you'll see this column here that's called is leader, and you see that master 2 is the current leader. So what we're going to do now is I'm going to exit out of this pod, and then let's do an OC debug. We're going to log in to this master 2 node. We're going to run the backup command. So in order to get into that master 2 node, we just run the OC debug node / master 2. I call it master 2 Ansible ocppocdemo.internal. And to use the host binaries, it tells you here just run chroot hosts or chroot host. And what we're going to do is back up we're going to back up the etcd state just in case. So I know that I know we've already removed the one etcd member, but it's better to do a backup just in case anything worse happens. I mean, in this case, we've only lost one master, but somehow if the database got corrupt for some reason, we always want to have a backup. And in a proper environment, you'd take backups as part of your day 2 operations. So I just want to let you know that. But so right now, what we're going to do is we're going to run user local bin cluster backup, and then we're going to store it in the home core assets backup directory. So it's doing the backup. It's going to give you a little bit of output here, and I'm going to cd in the home core assets backup directory, and you'll see a snapshot DB file and a static kube resources.tar.gz file. And again, in a proper environment, you'd want to have a copy of this somewhere else, stored for DR purposes. If you want to restore this cluster. As you'll recall from earlier, the node that we deleted was master1.ansible.ocp.poc.demo.internal, and you'll see it has a not ready state. So what we're going to do, since we know this instance of master1 isn't going to come back, we're going to have to rebuild a new master1. So what we're going to do at this point is basically remove that node. So we're going to do an OC delete node master1.ansible.ocp.poc.demo.internal. So now if you do an OC get node, you're going to see that this node no longer exists in the output. We're going to go back to the OpenShift etcd namespace, and let's see what pods we have listed here. So we see now the etcd master1 pod is now in a terminating state because that daemon set is, since there's only each etcd pod runs on each master. So now that there's no master 1, you're only going to see 2 instances of the etcd pods running. You're going to see it on master 2 and master 3. The one that's running on etcd on master 1 should now go into a terminating state, and it will eventually disappear. So what we're going to do now is RSH into one of the other etcd pods again, and then you'll see there's an inconsistent state here. Right now I'm running some OC commands. I'm getting a couple timeouts. Eventually it will come back. But right now, since the etcd's in a state where it's going to basically fix itself to so it can handle requests again. So you'll see now that the leader changed. Now we're going to do another OC get PO, and now you'll see it came back again. So the leader, it was in a state where things were changing. So what we're going to do now is let's RSH into one of the remaining pods. So we're going to go in the etcd master 2. And then we're going to do an etcd ctl member list -w table. And we see that the etcd member that's associated with master 1, its ID number or UID ends in 7C9. We're going to copy this, and we're actually going to remove this from the cluster because that member is never going to come back again. So we're going to do an etcd member remove, and then we're going to copy and paste that ID number. Now that ID number is removed at this point. So we only have 2 etcd members. Now there's actually some secrets that are linked to that master 1 that we deleted. So let's go back to the OpenShift etcd namespace. We're going to do an OC get secrets and then grep for master1.ansible. And we're going to see 3 secrets here. We're going to see an etcd peer, an etcd serving, and an etcd serving metric cert. We're going to delete each of those secrets. And you can do a for loop if you want, but in this case, I'll just show you us deleting each of these. Secret. Let's see, delete secret. Okay, and now we've deleted those secrets. All remnants of master 1 are now deleted from the OpenShift cluster. So we can now proceed with building a new master 1. So in the kube system namespace, you're going to see an instance of the root CA cert. And we're going to include that in the IGN file and the ignition file that gets used to add this master 1 node back to the cluster. So what we'll do now is we're going to do an OC describe config map root CA -n kube system. And you'll see the contents of that certificate. What you'll do now is, if we take that certificate, we take the contents of the certificate. I'm just going to create a separate file for it right now. We're just going to call this file ca.cert. Copy the contents here. Save the file. And now what we're going to do is we're going to do a base 64 encode of that. So I'm going to do cat on ca.cert. And then we're going to pipe that to a base 64 minus W0. And then we're going to output that right now to a temporary file called ca.cert.base64. And now if you do a cat on ca.cert.base64, you'll see the whole, basically see the whole string there. So what we're going to do is take the contents of this string, and I'm going to show you where we can basically take this. And you want to get all the way up to the, so I have a bash prompt here, but my bash prompt ends at that that hyphen, so I'm going to get everything up to that hyphen. And what we're going to do now is, I have a GitHub repo that has a sample of an IGN file that we can pull down. So what we're going to do now is go to my Git repo. If you go to github.com/kcalaga/adding_master_node, and then if you just go to the root of this, you'll see a master.ign sample file. What you'll do is take the contents of this, you can basically look at the raw version of it. We're going to copy and paste. We're going to grab this. Let's copy and paste this. We're going to use this as a template. We're going to edit the master.ign. And a couple things we want to change here are going to be the full FQDN of the API server. In this case, I have it called api.ansible.ocp poc demo internal. So I'm going to fill that in here. So we're basically going to edit this master.ign file, and we're going to put in the placeholders, we're going to put api-int. It needs to be the internal FQDN. That's what the certs, and that's the cert is issued in that name. So it's api-int.ansible.ocp poc demo.internal, and then we're going to basically copy the that string that we had, that base 64 string, to right after this base 64 comma, and then we're going to do everything up to that double quote at the end here. And this master IGN file is going to be basically in the root of my Apache web server. So when I boot this ISO, this will give it a location to be able to pull down from. Save it. So I'm just going to copy this master.ign of var.dub.html. That's where my web server is. And we're also going to download a copy of the ISO. The version of OpenShift I'm running on this cluster is 4.7.13. So what I'm going to do in my browser, I'm just going to go to mirror.openshift-v4/OpenShift-v4/dependencies/RHCOS/4.7/4.7.13. And I have a link to this also in the blog article as well. So what we're going to do is find the ISO image. So when we go here, there should be a RH CoreOS Live x86 64. We're going to download that. I'm just going to save this. I already have a copy of this, and it's also already up on my VMware server. So I just want to show you the location of it. So now if I go back to my VMware cluster, I'm going to go to Master 1. And if you remember previously, I deleted the hard drive for Master 1, and I added another drive back to it, just a blank one. So what we're going to do in this case is I'm going to go to the properties. I'm going to select an ISO file. And let's see here. I think I have my ISOs in my SSD store. And then I have an RH CoreOS 4.7.13 live ISO. We're going to select that one. And we're going to connect this at power on time. I'm going to save it. And now I'm going to power on that VM. And then when this boots up, we're going to type a couple commands here to force it to install. That's going to download that IGN file that I saved, and then install. And then the DHCP address that I have for Master 1, the MAC address is still the same. So the fact that you're seeing a Master 1 prompt, that's just because it's getting that over DHCP. What you want to look at in this case, it actually tells you which command to run. We're going to do the sudo and then space CoreOS installer. And then we're going to run this pretty much verbatim as it shows here. We're going to change. It's still devsda, and then the ignition URL in this case is going to be HTTP. I'm just going to give it the IP address of my web server. Master.ign. So it's my IP address is 192.168.100.1. Name of the file is master.ign. And we're going to pass an option at the end here called -- insecure ignition. And we're doing this because the ignition file is on a insecure web server. So let's try to run that. We're just going to let this run. Okay, it's been a few minutes. The ignition config's been written, and I'm getting a prompt here basically saying that the install is complete. I'm going to issue a reboot command now, and we're going to let this machine reboot a few times, and then a new CSR request is going to get generated here eventually. After the master node, after Master 1 reboots a few times, we're going to go back into the OpenShift cluster. We're going to see if there's any pending CSR requests. Right now you'll see there is a pending CSR request. So what we're going to do is we're just going to approve that one. So we're going to do OC ADM certificate approve, and then the ID associated with this cert. Okay, so that one's approved. Let's see if there's any new nodes that show up. No, it's not showing up yet. So what we're going to do, there probably be a couple other CSRs that will come in. So if we do a watch OC get CSR, okay, there's another one that's pending. Let's approve that one as well. OC. Let's see, OC certificate approve. I'm going to approve this other pending one. Let's see here. Get that. Now that's approved. Let's see if any new nodes show up yet. Okay, Master 1 is now showing up in the list. It's not ready yet, but it is showing up. So let's just wait for this to show ready. Okay, the Master 1 is now showing ready. So what we're going to do at this point, we're going to go into the OpenShift etcd project, and let's see if let's just see what's showing up here. So now we see a new etcd Master 1. And if we do an OC get PO minus O wide, we'll see, we'll basically see Master 1's got a etcd pod. Master 1 also has an etcd quorum pod as well. So at this point, let's go in. We're going to actually have to force a redeployment of the etcd cluster. Even though the pods are recreated, we still need to force this. We need to basically admit this new pod. Basically now we're going to issue a OC patch command. So it's basically OC space patch space etcd space cluster minus P equals spec force redeployment reason. We're going to do a recovery, and then we just put the date. That's just a comment, and we're going to merge that configuration. And that's also in my blog post as well. So once we issue that, what we're going to do is we're going to go back to the OpenShift etcd namespace, and then do another OC get PO. And we're just going to RSH into any of these pods. So we're just going to RSH into etcd Master 2. etcd-ctl member list minus w table. So now we're seeing all three members back. So we see Master 1, and then we'll also do a endpoint status command just to make sure that so there's a member list command, and there's also an endpoint status command we can run. Okay, and we're basically seeing all three members are there. The version matches, DB size, Master 2 is the current leader, and the indexes are all they're all at the same version. So I hope everybody enjoyed this article, and you'll see more to come. Thank you.